Hello everyone, here's a short video to show you what we stopped with. Yesterday we were waiting for the data to come in and that's how I couldn't show all this to you. So we are going to see how to plot an HR diagram with the data we have. I'll be sharing the data files with you and you can use them. So let me first share my screen and I hope you can see on my screen. I'm going to be opening TopCat, right? So in TopCat, I'm basically going to load the two data files which have the data. One is B-band data and one is V-band data. So if you can see my screen, this is the data which we got. So if you remember, I told you E91 means it's gone through Banzai pipeline and therefore I can upload the two files. So I will upload the two files and I will put this in FITS data format and okay, 1 minute. So I think it does not like me choosing two files at a shot. So I'm going to just pick up one. I'll pick up one and I'll say okay. Yes, now it's happy. And then I'll pick up the second one and here again it's going to be happy. So we'll take the second file, right? So here are both our files. If you remember, I told you each file has 4 subfiles. So for example, this first file is the science one, this one is the catalog, this one is the bad pixel mask, and here is the error file. Similarly, I have 4 more. So one is for B band and one is for V band. So let us open the catalog file and I'm going to open that in TopCat and you can see this is the catalog file, right? Now, if you remember, I explained to you what was a growth curve and it has basically built up a growth curve for different apertures, 6 apertures, and using that it's finally got the aperture at which it peaks, which is what we call flux. So you have a final file called flux. Now I'm going to generate from this, right click, okay, right click and make a new synthetic column. I think this will be B band and therefore I'll say 2.5 times log base 10 of flux, right? This will be my B band. Sorry, I spelled it wrong. I'll make it flux and I'll say okay. So this is my B band, okay? Similarly, in the second set of files, I'm going to look for the catalog file. This is the catalog file and therefore I'll take this. I again look for my flux column and next to the flux column, I get this here. I will right click, make a new synthetic column. I'll call it the V band column and I'm going to call it as 2.5 times log base 10 of again flux, right? So this is my V band column, okay? So now I have my B band data and V band data for both the files. So now what I'm going to do is very simple. I will use these double matchsticks. The double matchsticks are used to match both the files. So I will say the algorithm is by using 2D Cartesian and my 2D Cartesian, I'm taking it from the file number 2 and XY and then the other file is file number 6, right? So I'm taking this and I match this and you can see I have 5,226 pairs. So now I have a matched file. This is the matched file. I could have even plotted the result. I could have shown you maybe, but we didn't worry about it. So here we've got the matched file. If you see the matched file, I have these over here. And if you see here is this is coming from the first file. So it all has a suffix called 1. And if you look over here, you can see this is my B1A. And here, if you look over here, if you move here, this is my V, right? So what I'm going to do is I'm going to move my V a little close to my B. If I don't do that also, that's fine. So let me just get it over there. And what I'll instead do is I will just rename this B1A to B, okay? So I can right click it. I can say replace column. It's the same column. I'm just calling it B, right? And now what I do is I can now use this thing. This is for a scatter plot. Click this. And like I told you, an HR diagram is nothing but a plot of B versus B minus V or V versus B minus V. So my X will be equal to B minus V, right? Okay, it's not doing that. So let me get, where is B? Here is B. And I can say it's minus B. And here I can call this the B, right? So here's my HR diagram, okay? Which is where this is the brightness and this is the this thing, right? So have a look. This is an inverted scale. This one, the 15 is on top and this is an inverted scale. So this is an HR diagram. In a further time, we can check up about, this is all in apparent magnitudes. Now, if you want to convert it to absolute magnitudes, we obviously need distances. But at present, with our data, we don't have distances. If we were to match these stars, for example, with Gaia catalog, which has distances, we can get distances and convert it to an absolute scale. But as of now, this is all we have. So this is how you basically make your apparent HR diagram. Okay, so thanks a lot. Try getting it. Hope you all manage to do it. And if you do it, we will proceed with some more things in another workshop. Thank you. Bye-bye.